In part 1, we discussed the origins of the number 360 and why we have 360 degrees in a circle. Now, let's talk about radians and why we say that there are 2 pi radians in a circle. Remember that the letter pi represents a number. The first few digits are 3.14159, and those digits literally go on forever without repeating. You can mathematically prove that. Pi goes on forever. There are procedures for working out all the additional digits, but those first few digits are all we're ever going to need for programming graphics. In fact, we don't even want to use the digits, because nobody wants to type 3.14159 all the time. Ideally, we would just use the pi key on the keyboard. Of course, we don't have one, and that's why we have this special keyword pi. But still, where does that come from? Simply put, if you draw a circle with a radius of 1 meter and you walk around the circle, you will have walked 2 pi meters. That's about 6.28 meters. To see this, here's a circle of diameter 2. Now it might be 2 inches or 2 meters or 2 miles. The units don't matter as long as we are consistent. Let's use inches. So our circle has a diameter of 2 inches. Well, that's the same thing as a radius of 1 inch. If I start at one point and walk around the circle until I come back to where I started, how far would I walk? Since it's hard to measure the length of a curve, let's just unroll the circle. Now I have a straight line. I can measure the length of this line with a ruler, and if you do it, you get around 6.28 inches. Now if you measure it more and more carefully, you can refine that number more and more precisely and get more digits. And in fact, it literally goes on forever. Now people might have given this length, the unrolled circle, a Greek letter of its own. And in fact, some people have proposed doing exactly that. But instead, they took one more step. They took the circle of diameter 2 and the length of the unrolled circle, 6.2, and of course we know that those digits go on and on forever, and they divided them. If you divide 6.28 by 2, the number you get is the number we mean by pi, which has a value of around 3.1415. So if you measure the length of the line at the bottom, the distance we would walk if we walked around the circle, that distance is about 6.28 or 2 times pi. So we know that the distance around a circle of radius 1 is 2 pi. So what does any of this have to do with radians? Now I'll let you in on the secret. An angle in radians is nothing more than the distance around the circle within that angle. So for example, let's suppose that I have a circle with a radius of, say, 1 inch. If I have an angle of 1 radian, that means it encloses just enough of the circle so that if you walked along that arc, you would travel 1 inch. In other words, if you walk along the outside of the circle from the start of the angle to the end, and you measure the length you have walked, that is the angle in radians. So if I start at the green dot and I walk clockwise 1 inch, I end up at the red dot. Because I've walked 1 inch, we say the angle is 1 radian. I can measure this angle starting anywhere. We just start at the green dot, walk for 1 inch, and end at the red dot. Because we've walked 1 inch, we have an angle of 1 radian. Suppose I start somewhere else, and I walk 2 inches to my end point. Then if I draw lines from the center out to my starting and ending points, the angle formed is 2 radians. And as we saw before, it doesn't matter where I begin or end. If I'm walking 2 inches around the outside, I'm forming an angle of 2 radians. These are just 2 different ways of representing the same thing. Suppose I start somewhere on this circle and I walk half the way around. Well, that's a distance of pi inches. And so we say that the angle between those 2 circles is pi radians. So let's get rid of the inches and just think about this in general numbers. Suppose that we go the other way around. Suppose I say I have an angle of pi over 2 radians. That means I want you to start somewhere on the circle and walk pi over 2 units. And now you know the starting and ending points on the circle for an angle of pi over 2 radians. Let's see this in action. Here's a little sketch that shows us both the angle in degrees and the angle in radians at the same time. As always, we start at 3 o'clock and we go clockwise. So let's get down to, let's go half the way around. That's 180 degrees, or 1 pi. A quarter of the way around is 90 degrees, or half of pi. And of course, if we go all the way around, we're going to get 2 pi. And my program will go back to 0 if I get right into it. So let's get very close. You can see it's rounding out the numbers. Almost 360 is almost 2 pi. I can probably get just another pixel or two closer. Oh, and then it rolls around again. So 2 pi is the same as 360 degrees. 1 pi is the same as 180 degrees. Half pi is 90 degrees. And if we wanted 1.5 pi, that's the same as 270 degrees. So any number in degrees has a corresponding number in radians and vice versa. Both of these systems are around in processing because degrees are so handy for people. It's a great way for us to think about things between 0 and 360. But the computer, for numerical reasons, likes to work with radians, which go from 0 to 2 pi. Well, they're just two names for the same thing, and we can go back and forth easily. I find in my own projects, I usually type in and manage my numbers in degrees because they're easier for me to think about, and I hand them to the routine radians whenever I want processing to work with those numbers. If I let processing compute an angle for me and I want to print it out, I hand it to degrees first so I can make better sense of the number I'm seeing.